The solar system is unique 20–30% of the time in similar planetary constellations. The central star absorbs the planets that revolve around it. But if that's the case, why didn't this happen to us? The answer to this question may lie in the largest and oldest planet of the solar system, Jupiter. It is possible that before Earth, Venus, and Mercury, there have been other planets. However, they may have been destroyed by Jupiter, laying the foundation for the current solar system. In fact, what if we told you that Jupiter might have originated outside of our star system? Today, we'll talk about the hypothetical migration of the gas giant, as well as the way this may have affected life on Earth. As you know, Jupiter is a huge planet composed entirely of gas, mostly helium and hydrogen. The first studies of Jupiter took place back in the 17th century. However, many aspects in regards to this planet remain unsolved to this day. For example, Jupiter's most notable feature, the Great Red Spot GRS, is still controversial in scientific circles when it comes to its origin, length of existence, and color. Jupiter's rapid rotation around its axis, approximately 9 Earth hours, creates lengthy and powerful cyclones and anticyclones that can reach speeds of 335 miles per hour. The Great Red Spot is an anticyclone that has been around for over 300 years. However, the GRS is decreasing according to NASA. In the 19th century, the size of the anticyclone was estimated to be 25,500 miles in width. But now it is slightly larger than the diameter of Earth, 10,250 miles. The reason for the size decrease of the GRS is still unclear. But NASA scientists suggest that the answer may be some unknown activity in Jupiter's atmosphere which weakens the wind currents. Another mystery of the GRS is the signature red hue. NASA scientists suggest that the cause of the redness is a little-known colorless gas, ammonium hydrosulfide, and it forms sulfur when exposed to solar UV. What's more, NASA scientist Amy Simon believes that there's a correlation between the intensity of the storm's color and its speed. According to her research, the color of the GRS becomes more saturated when the wind speeds up. In addition to helium and hydrogen, Jupiter's atmosphere contains heavy elements such as nitrogen, argon, xenon, etc. However, these elements could only form at very low temperatures. Conclusion: perhaps Jupiter did not originate in the same place that it now occupies in the solar system. This gas giant could have theoretically formed 4 times farther away from the Sun. Jupiter might have been enriched with heavy elements and then headed towards our star, completing its formation. To understand the possible migration of Jupiter, let's take a closer look at how gas giants are formed. Gas giants form in a similar way to ordinary planets, but with a few differences. After a star is born from gas and dust clouds, the excess material rotates around the star, kind of like giant planetary rings. These rings are known as the protoplanetary disk, from which the planets are formed. On average, a protoplanetary disk only exists for a very short time on a cosmic scale, up to 10 million years. The disk consists of 99% gas and only 1% dust. As the dust particles crash into each other, thanks to gas, they stick together and form larger objects known as planetesimals. As they continue to gain mass, planetesimals eventually become planets, asteroids, or moons, depending on the amount of material. Planets with a solid surface are formed closer to the star. This is due to the fact that the radiation released after the birth of the star can't push heavy elements that make up the planets, like stone and metal, very far. Gas giants form away from the star, as radiation can push the gas farther away. However, a lot of gas is not enough to become a gas giant. These planets must also have a massive solid core to attract gas. So how do the gas giants form such large nuclei if the building materials do not reach them in the quantities they need? According to the research of astrophysicists Kobayashi and Tanaka, These giants can build up large core masses thanks to pebbles that are pulled into the solar system due to the orbit of Neptune. Additionally, the ice particles that are pushed out by radiation as vapors can act as a building material for the core. Finally, it is possible for gas giants to be born outside the planetary system and then migrate into narrow orbits. The hypothesis of such planetary migration is called the Grand Tack hypothesis. The Grand Tack hypothesis, proposed by Kevin Walsh of the Southwest Research Institute in Boulder, suggests that Jupiter likely originated much farther away from the Sun than its mass as it migrated toward the Sun. Also, this hypothesis suggests the migration of Jupiter may have caused the emergence of the asteroid belt and even the insufficient mass of Mars. According to a study by a team of astronomers at Lund University, the future gas giant may have potentially originated in the outer region of the solar system as an icy asteroid. After 2 to 3 million years, Jupiter likely accumulated a mass almost equal to our planet and began to shift towards the Sun. Researcher Sho Shibata explained that Jupiter may have been about 20 AU from the Sun when the solar system was first formed. Affected by gravity, the gas giant headed towards the Sun. On its journey towards the Sun, Jupiter likely chose a very successful path, which was filled with the material necessary for its development. Streams of gas that were still orbiting the newborn Sun were most likely picked up by Jupiter. The gas giant went in a spiral and took a total of about 700,000 years. Hypothetically, Jupiter may not have been in the same place where it is now. The gas giant potentially occupied the current place of Mars. Over time, Jupiter must have migrated to the new space it now occupies in the solar system. A likely proof of Walsh's hypothesis is a group of asteroids called Jupiter Trojans. These asteroids surround the planet from two sides, the front and the back. While exploring these mysterious asteroids, scientists have been very puzzled as to why the group of Trojans in front of Jupiter is twice as large as the one behind. Thanks to computer simulations, scientists at the University of Lund in Sweden have concluded this is a symmetry and is probably caused by planetary migration. Based on that hypothesis, during the internal migration, Jupiter's gravity widened the particle path, securing more Trojans in front of it. Scientists suggest that the Jupiter Trojans may have been part of the Kuiper belt, which is located beyond the orbit of Neptune. These asteroids had the potential to allow scientists to explore materials left over after the birth of the solar system without sending spaceships that far. Naturally, the significant space maneuvers of a giant planet could not have left our solar system unaffected. The most compelling evidence of the Grand Tack is Mars. It's possible that without the intervention of Jupiter, the red planet would have been larger than Earth. Mars was formed around the same time as Jupiter, so it had the time and opportunity to accumulate significant mass. However, Mars is only about 4,225 miles in diameter. And for reference, the diameter of the Earth is 7,955 miles. So Mars is about half the size of our home planet. Jupiter is most likely to blame for this. When the gas giant got close to the Sun, it may have absorbed or dispersed the materials that were intended for Mars towards Earth and Venus. Jupiter's mischief doesn't end there. There is an asteroid belt between the orbits of Mars and Jupiter. It covers approximately 140 million miles. The belt mainly consists of small asteroids, although it also contains several larger bodies. For example, there's a dwarf planet, Ceres, as well as large asteroids up to 400 miles across, including Vesta, Pallas, and Hygeia. It is possible that another planet could have formed from the spell. However, according to the Grand Tack hypothesis, its formation may have been prevented by the gravitational forces. Because of the gas giant, the planetesimal were not able to unite and simply fell apart. It's possible that Jupiter may have also dispersed. a significant amount of materials in the process of migration. Therefore, even if it were possible to switch off the influence of Jupiter, the mass of the belt would not be sufficient to form even a small planet similar to Mars. Finally, the least apparent but most significant consequence of Jupiter's migration was the likely destruction of the first planets in our system. The solar system is really different from other systems. Many of the known planetary systems, similar to ours, have super-Earths in their composition. These planets are larger than Earth and consist of either rock or gas, or a combination of both. So why don't we have planets like that in our system? Astronomer Konstantin Badagan suggests that such planets may have existed in the early days of the solar system. However, it's possible that Jupiter destroyed the first generation of planets. The gravitational influence of Jupiter, which hypothetically traveled close to the Sun, and then back to its current orbit, where it is now, led to the collision of the forming planets. In fact, Jupiter may have set the stage for the formation of the planets we know, and of course, the planet we live on. However, the formation of planets takes a very long time. From humanity's point of view, several million years. Therefore, Mercury, Venus, and Earth continued to develop from an already slightly depleted protoplanetary disk. Delayed formation explains the small size and thin atmosphere, as well as the age difference between the outer and inner planets. Admittedly, it is possible that it was Jupiter that influenced the current structure of the solar system, the annihilation of the first planets, and the obstruction of the development of Mars may sound like negative events. However, Jupiter's intervention may have had positive consequences for us. What if we told you that the gas giant's migration probably gave the opportunity for life to evolve on our planet? The mystery of the huge amount of water present on Earth is still unsolved in the scientific community. The oceans could not have come into being at the same time as our planet, since all water would have evaporated due to the very high temperature during Earth's formation. However, water probably existed inside our planet, but there was not enough of it to cover 70% of the Earth's surface. The small asteroids are considered to be the most likely source of water, having contained water in the form of ice. Over the course of its migration, Jupiter may have sent these asteroids in our direction. Moreover, according to astronomer Phil Plait, in addition to water, meteorites containing building blocks for living organisms, that small asteroids that reach Earth, such as amino acids from which proteins are formed. Therefore, Jupiter may have been one of the reasons for the origin of life on Earth. In a way, Jupiter can even be considered our shield, to some extent. The gravity of the gas giant can change trajectories of dangerous asteroids and comets, steering them away from Earth. Furthermore, Jupiter is capable of absorbing comets that have the potential to become a threat to other planets. For example, in 1994, the 1.2-mile comet Shoemaker-Levy 9 crashed into Jupiter. If this had reached Earth, all life on our planet would have been doomed. However, in order for water to exist on Earth as abundantly as it does now, Jupiter most likely sent asteroids in our direction. That is, Jupiter does not always protect us. On the contrary, it can also be a source of attack. Professor Dante Horner of the University of Southern Queensland has determined that Jupiter increases the risk of asteroids colliding with our planet. Nevertheless, if Jupiter had a smaller mass, it would have dramatically increased the possibility of cosmic bodies reaching Earth. Therefore, Jupiter definitely plays an important part in our life. But it also has the potential to harm it. Interestingly, there's another subtle influence that Jupiter has on Earth. The Earth's orbit is almost perfectly circular. However, due to Jupiter's gravitational pull, it can stretch into an elliptical shape. This deformation of the orbit will lead to significant climate changes. The summers become much hotter and the winters much colder. Of course, this does not happen very often, only every 400-5,000 years. But we're currently in the midst of that cycle. The migration of Jupiter has not yet been confirmed and requires further research. However, it's likely that without the gas giant, our solar system would be completely different. It is possible that without its influence, life on Earth may not have existed at all. In 2021, NASA sent the Lucy spacecraft to explore the Trojan asteroids. Perhaps its expedition will reveal more data to confirm the hypothesis of Jupiter's migration, and may also allow us to study the material from which our universe was formed more than 4 billion years ago.